Space has always captivated humanity. We look up at the stars and wonder about the vastness of the universe. We dream of other worlds, of planets beyond our own. What if those planets were more like Earth? Imagine our solar system, but every planet is the same size as our home. What would happen? Would these new Earths be habitable? Could life exist there? Let's explore this cosmic thought experiment. We begin by understanding the diversity of our solar system. From scorching hot Mercury to distant icy Neptune, each planet has unique characteristics. These differences are largely due to their size and distance from the Sun, but what if we removed that size difference? This essay is a journey into that what if. We will examine the potential consequences of all planets becoming Earth-sized. Using scientific principles, we'll delve into how their atmospheres, temperatures, and surfaces might change. We'll also consider how this drastic alteration would affect the solar system's delicate balance. Fasten your seatbelts and prepare for a thrilling ride through the cosmos. Our destination, a solar system transformed. Before we embark on our hypothetical journey, let's understand the current state of our solar system. The planets are locked in a delicate gravitational dance. The Sun, a giant ball of burning gas, exerts a powerful gravitational pull that holds the planets in their orbits. The inner planets, Mercury, Venus, Earth, and Mars, are relatively small and rocky. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants, much larger and more massive. Their size and composition play a crucial role in the solar system's stability. This stability is maintained by a balance of forces. Gravity pulls the planets towards the Sun, while their orbital momentum keeps them moving in their elliptical paths. Any significant change in a planet's mass would disrupt this balance. Now imagine all planets shrinking or growing to the size of Earth. This drastic alteration would have profound consequences. The gravitational forces between the planets would shift, potentially leading to collisions or planets being ejected from the solar system. Buckle up, because things are about to get interesting. Let's start with the inner rocky planets, Mercury, Venus, and Mars. Each of these planets would undergo a dramatic transformation if they were Earth-sized. Mercury, the smallest planet, would experience the most significant change. Its weak gravity currently struggles to hold on to an atmosphere. With increased size and gravity, Mercury could potentially hold on to a thin atmosphere, possibly composed of elements outgassed from its interior. However, its close proximity to the Sun would still make it scorching hot. Venus, our superheated neighbor, would also experience a dramatic shift. Its thick, toxic atmosphere traps heat, making it the hottest planet in our solar system. An Earth-sized Venus might be able to regulate its temperature better. However, its volcanic activity and potential for a runaway greenhouse effect would still need to be considered. Mars, the red planet, is often seen as a potential second home for humanity. An Earth-sized Mars could potentially hold onto a thicker atmosphere, possibly leading to the presence of liquid water on its surface. However, its lack of a global magnetic field would still be a challenge for life as we know it. The transformation of these rocky planets would undoubtedly be a sight to behold. But what about the gas giants? Let's find out. Moving on to the outer solar system, we encounter the gas giants, Jupiter and Saturn. These behemoths are vastly different from Earth, composed mostly of hydrogen and helium. Shrinking them to Earth size would have mind-boggling consequences. Jupiter, the largest planet, would experience the most dramatic change. Its immense gravity affects the entire solar system. If it were Earth-sized, its gravitational pull would significantly weaken. This change could disrupt the asteroid belt, potentially sending asteroids hurtling towards the inner planets. Saturn, known for its stunning rings, would also undergo a dramatic transformation. Its rings are made up of ice and rock particles held in place by its gravity. A smaller Saturn would have weaker gravity, potentially causing its rings to disperse or even collapse onto the planet. The fate of these gas giants is uncertain in our Earth-sized solar system. Their composition, atmosphere, and even their very existence would be called into question. It's a cosmic mystery waiting to be unraveled. Section 5, Ice Worlds Awakened, Uranus and Neptune's Transformation. Venturing further into the depths of our reimagined solar system, we encounter the ice giants, Uranus and Neptune. These distant worlds are composed mostly of ices, water, ammonia, and methane surrounding a small rocky core. How would they fare in an Earth-sized solar system? Uranus, the tilted giant, is known for its unusual rotation. An Earth-sized Uranus would still be an icy world, but its lower gravity might mean a less dense atmosphere. This could potentially affect its weather patterns and overall climate. Neptune, the blue planet, is known for its strong winds and active storms. A smaller Neptune would likely have less internal heat, potentially leading to less turbulent weather patterns. However, its atmosphere would still be composed of similar elements, giving it its distinctive blue hue. The transformation of Uranus and Neptune would be less dramatic than that of the gas giants. However, their icy nature would still be a defining characteristic, even at Earth size. But what about Pluto? Let's find out. Pluto, no longer the odd one out? No discussion about the solar system is complete without mentioning Pluto. Once considered the ninth planet, Pluto was reclassified as a dwarf planet in 2006. But what if it were Earth-sized? Pluto is a small, icy world located in the Kuiper Belt, a region of icy bodies beyond Neptune. If it were Earth-sized, Pluto would be a much more dynamic world. Its increased gravity could potentially allow it to hold on to a thin atmosphere, possibly composed of nitrogen, methane, and carbon monoxide. However, even as an Earth-sized world, Pluto would still be incredibly cold due to its distance from the Sun. It's unlikely that life as we know it could exist on such a frigid world. Despite its icy nature and distance from the Sun, an Earth-sized Pluto would undoubtedly be a fascinating world to study. It would provide valuable insights into the formation and evolution of icy bodies in the outer solar system. But how would all these changes affect the solar system as a whole? Let's explore the gravitational dance of our reimagined planets. A new solar system dynamic, the dance of gravity. With all planets now the size of Earth, the solar system's delicate gravitational balance would be thrown into disarray. The most significant change would be the shift in the barycenter, the center of mass around which the planets orbit. Currently, the Sun's massive size means the barycenter is located very close to its center. However, with all planets the same size, the barycenter would shift significantly, possibly even outside the Sun's surface. This shift would alter the orbits of all the planets, making them more elliptical and less stable. The gravitational interactions between the planets would also be affected. Planets that are closer together would exert a stronger gravitational pull on each other, potentially leading to orbital resonances or even collisions. The asteroid belt, located between Mars and Jupiter, would also be affected. The gravitational influence of a smaller Jupiter would be weaker, potentially causing asteroids to stray from their orbits and pose a threat to the inner planets. The stability of our reimagined solar system is uncertain. It's possible that the planets could settle into new, stable orbits over time. However, it's also possible that the system could become chaotic, leading to collisions or planets being ejected into interstellar space. It's a cosmic game of chance, and the stakes are high. The seeds of life, could they sprout on new Earths? The possibility of life on other planets has always captured our imagination. In our Earth-sized solar system, would the seeds of life have a chance to sprout? The answer is complex and depends on a multitude of factors. While size is important, it's not the only factor determining a planet's habitability. Other crucial elements include the presence of liquid water, a suitable atmosphere, and a stable climate. In our reimagined solar system, some planets might become more habitable, while others might become less so. For example, an Earth-sized Mars with a thicker atmosphere could potentially support liquid water on its surface, making it a more promising candidate for life. However, the gravitational instability of our reimagined solar system could make it difficult for life to gain a foothold. Frequent asteroid impacts or drastic changes in orbit could wipe out any nascent life forms before they have a chance to evolve. While the possibility of life in our Earth-sized solar system is uncertain, it's a tantalizing thought. The universe is full of surprises, and life might find a way to thrive in the most unexpected places. The search for life beyond Earth continues to inspire us. It reminds us that we are part of something much grander than ourselves, a cosmic tapestry woven from stardust and wonder. Our journey through a hypothetical solar system with all planets the size of Earth has been a thought-provoking experience. We've explored the potential consequences of such a drastic change, from the transformation of individual planets to the overall stability of the solar system. While the scenario we've explored is highly unlikely, it highlights the delicate balance of our own solar system and the vast diversity of planets that exist in the universe. It reminds us that our understanding of the cosmos is constantly evolving as we continue to explore the universe and uncover its mysteries. The universe is full of possibilities, from planets with two suns to rogue planets wandering interstellar space. Each discovery expands our understanding of the cosmos and inspires us to ask new questions. As we continue to explore, we may find that truth is stranger than fiction, and the universe is far more wondrous than we ever imagined.